One of our biggest challenges in 2024 was our box wing project, where Rene and I tried to make both a land-based version as well as a water start and water takeoff version of the aircraft. One of the biggest challenges was to create a hull that would allow our model to take off from water and land on water.
The box wing still is diving too deep in the water. These outer pontons should stay about this way. So we need 2 more centimeter lift. I think the whole fuselage should be more wide underneath. Yeah. It's still a lot of things to do. Even when there is big progress, it's still not perfect.
It was at this point that Rene and I decided to review the hull and give the hull a brand new style and design. One of the first most important things was to find out what type of displacement our model was currently at, and I used a very basic principle of calculating the weight of the finished completed model and finding out how much equal volume of material that would displace. So here I created a rectangular prism in SolidWorks and removed or subtracted, using the combine feature in SolidWorks, the hull from the block, and in this instance take the volume of the original block and subtract the hull from it, leaving a displacement amount which I could then use as the basis for understanding how deep our hull would be sitting in the water once I increased the hull capacity and design. As I'd never designed a seaplane before, I went online and searched on the internet for some information regarding the design of seaplanes, and I came across a book, The General Aviation Aircraft Design, Applied Methods and Procedures by Snorre Gudmundsson. In Appendix C3 there was some very useful information regarding the angle of the hull relative to the outer pontoons, the angles of chines, and the surfaces and surface areas to which I was able to adjust my 3D model. In this instance here I used SolidWorks to establish a new datum for the base of the keel, and from the front view established the start point for that new keel line, and so in side view it was then possible to reorient the keel on the 3D model and develop that so that it would provide us with a lot more buoyancy and a steeper hull. Throughout the entire hull design and development process, I employed the tools fill surface, boundary surface, and knit surface predominantly to re-establish a 3D shape, which I was then able to fully close and reassemble as a solid body, and in doing so was able to then use the new volumes to establish the displacement of the newly created hull. Once I'd re-established the solid body of the aircraft, I was able to reinsert that into the block and subtract the volume of the aircraft relative to the block and determine the exact position at which the aircraft would sit in the water. After our hull redesign process, Rene reprinted the parts and built another box wing to trial out on the pond. Despite the small pond, the water tests were crucial for Rene to establish the power and the performance of our little box wing, and we made some discussions about increasing the size of the props to provide more thrust, as well as adding a winged surface to the hull to create a planing hull design to lift the entire aircraft out of the water once it was under speed. This led us to develop a complete new wing design to the hull on the underside of our box wing, a planing surface, and I used SolidWorks to develop that particular geometry and get our entire hull to a position where both the outer pontoons would not provide any resistance on the water surface. It would allow more yaw control and the ability to turn the aircraft on a water surface. We also added the front gates or slats to the wing to increase performance, as well as increase the size of the propellers. Having completed the redesign of the hull with the lower wing, I reinserted that into SolidWorks and established the draft, or the depth at which the model would sit on water once we took it out into the field.
Over the water makes the yaw much easier. You can see it's super maneuverable, and it also helped when
It was great to see the box wing sit just as planned as per the SolidWorks simulations that I had done, and it was also incredible to see the small little box wing take off from the water based on our latest lower wing design on the hull. Hampered by the surrounding obstacles on the pond, Rene did manage to land our box wing. Not the most elegant way, but it did show the robustness of the design and also the ability to do a very short landing and still survive. It's been so much fun developing this sketch that I created in 2014 with Rene Rosentraeger and developing the 3D model files for a fully functioning amphibious experimental 3D RC model. We've made the files available on our joint website aerojtb.com, where you can download the STLs and print your own box wing.